Hi there, everybody. Welcome to another Chem Complete episode. We're going to be working on Organic Chemistry 2 today, and we are going to take a look at acetyl formation. You could also call this ketal formation if you're using a ketone, but it's typically called acetyl formation. It stemmed from the aldehydes that were originally used, but this will work with an aldehyde or a ketone. So let's get started on taking a look at the mechanism and this reaction. So for acetyl formation, it's going to be kind of similar to the amines and the enamines that we have seen. You're going to start with an aldehyde or ketone. We'll go ahead and work with a ketone here. Let's just do acetone to keep things simple. And acetyl formation is a reversible reaction similar to the amines and enamines. So what we're going to use is some sort of an alcohol, which would be ROH. I'll just go ahead and use methanol here as an example. And this is, again, acid catalyzed as we're working with this. So the first step, which should be familiar to you if you saw the amines and enamines, and hopefully you did watch that video, is that this oxygen would go after the acidic catalytic proton in order to basically activate this carbonyl complex. Whoops, let's put that on that side. So when we do that, we end up with the alcohol in the double bond form. That's going to activate that ketone to an incoming nucleophile. And in this case, the incoming nucleophile is going to be the alcohol itself. That'll come in to the carbonyl group, which will make room by releasing a set of the pi electrons up to the oxygen. So once we're at this step, if you come down here, what we end up with is we've got a protonated alcohol that came onto that carbon. So down here, or actually I can show it off to the side here. Let's move the CH3 down here. So here's where the alcohol came in. It was the oxygen that actually donated the pair. So it's got a hydrogen and it's got the CH3 group here, right? Or whatever your R group would be. There's a plus charge on that oxygen because the alcohol was neutral and it gave electrons over to the carbon here. And then this is also an alcohol. That's the original ketone carbonyl group that was there. So this particular hydrogen, because this was a catalytic hydrogen, catalysts will regenerate themselves. So many times in the mechanisms, you just need to show the electrons from this bond returning to the oxygen, and the hydrogen will essentially be leaving out into solution when that occurs. So you'll be getting your acidic proton back. And if that happens, let's actually make room here. So I'm going to go down one more. All right. If that happens, you're going to end up with this somewhat stable intermediate form, which is the ketone portion has turned into an alcohol, and I have the additional OCH3 portion. So this is known as a hemi-acetyl. I guess technically you could call this a hemi-ketyl since it's coming from a ketone, but this is a halfway, a halfway point to the acetyl. So it's going to be two of these ether groups that make up the acetyl. So you're going to basically run through this again by and large. Now you don't have a ketone anymore, so the alcohol is going to need to be protonated. So we're going to take this alcohol right here. Remember, we just released this hydrogen into solution, so we've got our catalytic H plus back. This will gladly pick that up. And so when that happens, okay, I'm going to end up with CH3, CH3. The hemi-acetyl portion is still there, and now I have water. So remember, when water is attached to a carbon, it makes a good leaving group with that positive charge. So this will gladly leave, taking electrons with it. Now, it depends on your instructor. Some instructors here will show a carbocation forming, which isn't particularly wrong. I suppose that you could show that. Many instructors will show, especially since you have the ability to do this, it's not like you only have alkyl groups here. You have an oxygen with lone pairs available to basically move in and perform some sort of resonance. And so a lot of times you will show that this moves in to form a temporary double bond here. And so what happens, the water gets kicked off, and we end up with a structure, CH3, C, CH3, O, CH3, and that OCH3 is double bonded to this carbon right here. So the oxygen has the plus charge in this case when we're looking at this. So carbon still has 4 bonds. That's fine. I'm not violating any type of valence rules. And then what's going to happen is the second alcohol will come in at that point. Oh, I'm getting ready to write R here. We're using a specific alcohol. So another methanol is going to come in. And you're going to see the carbon is attacked and the electrons that were borrowed go back to that oxygen. So we're almost there. Okay, because what we have now is we have CH3, C, CH3. I get the OCH3 back, and now I've got a new OCH3. It is protonated because it came in as an alcohol. So the same thing is going to happen. This is going to leave and give you the H plus back. And so the final structure will be 2 of these ether groups that are present on the compound. So just to clean that up, now that we've run through the mechanism, what we're saying is if you have the following, acetone, right, and you used methanol with H plus, the final result would be CH3. Here's the carbon that would belong to the carbonyl, CH3. So this portion right here you can see right here from the acetone. And then I end up with OCH3 and OCH3. And this is your acetyl, or again, some people call these ketals. That would specifically be if it was from a ketone, but generally the groups are just called acetyls when we're working with them traditionally. So that is acetyl formation. This is a full acetyl. We already discussed there are hemiacetyls that you can form. And the one thing I want to mention before we start to wrap this up is that this reaction, because it's reversible the entire way, is excellent to protect ketones and aldehydes. So many times this reaction will be used to put these groups on here. They protect the ketone portion, and then they will be removed subsequently by just adding acid or H3O+. Remember back from the ether chapter that ethers are subject to acidic cleavage, and so that's exactly what you have here. You have 2 ethers, and with acid you can acidically cleave those ethers to give you the ketone back. One of the ones that looks a little bit funky sometimes is, and this one tends to be used quite often as a protecting group, you have a ketone or an aldehyde, and you use a diol as the acetyl agent. So I use, instead of just a single alcohol, I use something like this, a diol. And so when you do this, you don't need 2 equivalents of it like you would with a methanol or the ethanol in order to get the 2 ether groups. This has 2 alcohols built in, and so this will be one part of the ether, and on the same chain that will be the other part of the ether. All right, so we say, we include this with H+. What's actually going to happen here, I'm not going to run through the whole mechanism, maybe I'll have a practice problem like that I put up later. What's going to happen is you're going to say, okay, well, normally I had this, and then I had 2 of those ether groups that were coming off. Well, in this case, we have this, which is attached to CH2, and then the other alcohol on the other end acted as the other ether group. So you get something that looks like that. And so many times in class, you're going to see your instructors drawing this really funky looking thing. It looks almost like some people call it a hat, right? You see that? This right here is an acetal formation. Whoops, acetal, using a diol. And if you ran through the mechanism, I think you could figure that out based on what we had. So that's it. That's where I'm going to leave it. This is the acetal formation. Remember, there's also a hemiacetal. This is completely reversible. It's very good for protecting ketones and aldehydes. And other than that, hopefully you guys found this useful. Please remember to like if you found this video helpful. Commenting if you have questions or comments. I'm happy to take feedback and answer questions for you guys. And subscribing will, of course, always get you the quickest way to all the new videos. So I hope that you subscribe, and it really helps me out and helps the channel out so I can keep producing content for you guys. Other than that, have a good one, and I will see you for the next lecture where we will continue aldehydes and ketones. Take care, guys.